Science fiction is a huge part of our entertainment, and in it we see humanity make use of extremely advanced technology. In these futuristic worlds, the technology is so advanced that it looks to us like magic, making use of materials that are far beyond what we could hope to create today. Or are they? In 2004, Professor Sir Andrew Geim at the University of Manchester created the world's first ever sample of graphene. Since then, research into the material has exploded, and the list of possible applications for it grows every day. Graphene is unique in being the world's first two-dimensional material. It's made entirely of graphite, which at the molecular level is a hexagonal lattice of carbon atoms. Graphene is different than graphite as it is only a single atom thick, making a material that was not even thought to be possible before the first graphene was created. Graphene has been called a wonder material because of its amazing properties. It is the best thing we know of at conducting heat and electricity, and its strength relative to its weight makes it the strongest material known to man at over 350 times as strong as Kevlar. These properties give graphene the potential to impact nearly every field of science and even create new ones. The main hurdle in the practical use of graphene is in its production. The first graphene in 2004 was made by taking regular pencil graphite, peeling off a strip with adhesive tape, and repeating the process until the remaining graphene was only a single atom thick. This process is very slow, and since then scientists have gotten farther along in creating an efficient process that can mass produce graphene. Recently, researchers at MIT made a breakthrough in one of these processes, yielding graphene at a rate of 5 centimeters per minute, the fastest it's ever been produced. When producing the graphene, they start with a small amount of carbon, called a seed. From there, they grow more carbon onto the seed by bombarding it with high temperatures, pressures, and a mixture of hydrogen and methane gas in a method called chemical vapor deposition. As the carbon atoms attach to the graphene, they self-arrange into the hexagonal lattice. They also use the roll-to-roll method, where the graphene is moved along a copper plate as it grows, making room for more to form. This method is one of the first that is scalable, meaning it could be repeated in a factory for mass production. Despite being considered a breakthrough, making graphene with it is still slow and expensive, but it is one of the many advancements in the production of graphene that will come before it's used in our everyday technologies. When it does, it promises to have applications in longer-lasting batteries, space travel, water filtration, and much more. Our methods of graphene production have a long way to go before we see it being used in the useful, practical technologies we use daily. But once it does, it will make breakthroughs in every field of science from medicine to space travel.